All right, in this explainer, we're going to unlock the official mark scheme for question 2 of the AQA GCSE Chemistry higher tier paper from June 2024. We're going to dive deep and see word for word what the examiners were actually looking for so you know exactly how to bag every single one of those marks. Let's get right into it.
So the plan is simple. We're going to walk through the official mark scheme step by step. We'll look at the exact phrases that score the points, what other answers they'd accept, and those little details that can make all the difference between a good grade and a top grade.
Okay, so here's the diagram they gave you for question 2. It shows a simplified Haber process, right? You've got nitrogen and hydrogen going into this reactor, liquid ammonia coming out of the condenser, and then there's this pipe P that connects the two. And that first question, it's all about what that pipe is actually for.
So for 1 mark, question 2.1 asks simply, why is the condenser linked to the reactor? You know, this is really all about making the process as efficient as it can possibly be.
The top scoring answer, the one that is guaranteed to get you the mark, is to recycle the remaining nitrogen and hydrogen. The key word there is recycle, and you've got to name both gases. That combination is a dead cert for 1 mark.
But the good news is they're a little bit flexible. The examiners also accepted to recycle unreacted gases, or to return nitrogen and hydrogen to the reactor. As long as you clearly get across that core idea of returning the leftover gases to be used again, you get the mark.
Okay, let's move on to 2.2. This one's a classic. Just straight up recall.
They ask, which metal is used as a catalyst in this reaction? This is one of those absolute core facts you just have to have locked in for the Haber process.
And the answer? It's just one word, iron. That's it. No need for a whole sentence. Just the name of the metal gets you that 1 mark. Simple as that. And hey, here's a great little exam tip for you. The mark scheme confirms that the chemical symbol Fe is totally fine. It's correct, and it saves you precious seconds in the exam. It's a win-win. All right, now the question takes a bit of a turn. We're shifting gears from making ammonia to using it to produce nitric acid. And this is where they test your knowledge of a standard lab procedure.
Question 2.3 is a classic 2-marker, and it's one where it's so easy to accidentally drop a mark. You have to answer both parts. First, describe the test for oxygen gas, and second, give the result if oxygen gas is present.
Now, this is a perfect example of how examiners think. Mark number 1 is for the test. You need to say glowing splint. Mark number 2 is for the result. It relights. But, and this is the absolutely crucial part, the second mark is dependent on the first. If you get the test wrong, you get 0 marks for the result, even if you mention relighting. It's an all or nothing 2 marks.
Okay, let's get visual. We're now moving on to the reaction profile questions, where you need to show you can read and complete one of these diagrams.
So, have a look here. On the left is the blank canvas they gave you in the exam paper, and on the right? That's the masterpiece, the perfectly completed version straight from the mark scheme. This is exactly what a 2-mark answer should look like.
So how do you get there? Well, for the first mark, you needed to draw a vertical arrow for the activation energy and label it. That's the energy hump it has to get over, going from the reactant level right up to the peak. The second mark was for correctly labeling the reactants, ammonia and oxygen on the left, and the products, nitric acid and water, on the right. It's all about being precise.
Then came 2.5, a multiple-choice question asking how the profile would change without a catalyst. The correct answer is the line would reach a higher peak. And why is that? Well, a catalyst provides a shortcut, right? An easier path with a lower activation energy. So if you take that catalyst away, the energy barrier, that peak, is going to be higher. And for the final part of question 2, we're on the home stretch now, it's an application question.
Suggest one use of ammonium nitrate. Now this is the salt formed when the ammonia we started with reacts with the nitric acid we've just been talking about. So, what do we actually use it for?
The main answer, the one they're almost certainly expecting to see, is fertilizers. It's an amazing source of nitrogen for plants, which helps them grow. Write that down and you've got the mark. No problem at all.
But, just like before, there are other correct answers. You would also have been awarded the mark for suggesting explosives or even sports injury packs, as the chemical properties of ammonium nitrate are used in both of those.
So there you have it, a complete mark-by-mark breakdown of question 2. You know, looking at the mark scheme like this really shows how vital exam technique is. It's not just about knowing the chemistry, it's about using keywords like recycle, understanding how marks can depend on each other, and knowing when a simple symbol is enough. Now that you've seen inside the examiner's head, How will that change your approach to answering questions? Something to think about for your next revision session.